This video will focus on doing problems that have to do with hydrates. Okay, there's two different types of problems we can do. We'll either have to determine the formula of the hydrate given data, or from the actual formula of the hydrate, talk about percent of water by mass. Right. So here's the first type of problem, and in my opinion, probably the easier problem. Okay, you're given the hydrate's actual chemical formula, and you're asked just from this formula, what is your percent by mass of water? Okay, from this formula, we're given the mole ratio of the ionic crystal to water, and from that, we're going to get the mass percent of water. The most important thing to remember when you're working with a percent is you always want the thing you're looking for to be your numerator, and then the total is always your denominator. So we just have to figure out what the mass of water is in the mass of total to get to the percent of water by mass. The easiest way to do this then is to use the chemical formula that's been given to you. If we imagine we had one of these ionic crystals, like 1 mole of this, in 1 mole of this anhydrate, we have 10 moles of water. Okay, so if that's our sample we're working with, 1 mole of this and 10 moles of this, we can go mole to gram using your molar ratios, and from that get your mass of water in this formula and your mass of total, which is the entire formula. So here's how I always set up all kind of hydrate problems. There's 3 pieces of information that you may need to find or use. The 3 things you may use is your anhydrate, your hydrate, and your water. Okay? In this case, our anhydrate is this thing right here, and it's 1 mole per 10 moles of water. So if you have 1 mole of this, that'll just be your molar mass. So if you add this guy up, you'll find that the molar mass of your anhydrate is this. Okay, that is the mass of your anhydrate. For your water, in this proportion again, for every 1 mole, you have 10 of water. So if I have 10 moles of water and I want to get that into a mass, molegram, the molar mass of water is 18.015 grams per 1 mole. So you times that by 10 then to get the mass of water in this formula. Your hydrate then is just always the summation of your ionic crystal and your water. So it's these 2 things added together to get your hydrate. Okay, so we have our anhydrate, our hydrate, and our water. And if we're going to get a percent by mass, we can take the mass of water divided by the mass of total. Our mass of water is right here. The mass total is always your mass of your hydrate because that's the total stuff. Okay, so I'm just going to take the mass of the water divided by the mass of the total. Times that by 100 to get it into a percent, and we get our final percent then of water to be 62.96%. Sig figs, not really something you can think about in this problem since we're using molar masses to calculate. Okay. So to get your percent by water, you got to get the mass of the water in the hydrate, which is just the mass of water times whatever this number is here. You get the mass of the anhydrate, add up, and then you just divide. The other problem type, which tends to be more complicated for people, is trying to get the chemical formula from lab data. Okay, so if you read this, you know you have a hydrate, but you don't know at what ratio the water is. But you have data. Okay, you have information about the hydrate, you have information about the anhydrate, and the question is, what is the formula? So in this problem, what you're solving for is this X. You know you have cobalt chloride. You know you have water because it's a hydrate, but you don't know at what ratio this is. Remember, what this X represents is a ratio between this ionic crystal and this water in terms of their mole. So it's a mole ratio. It's some number versus 1 mole of this. Again, I have my data. I have my mass for my anhydrate. I have my mass for my hydrate. And just like my last problem, I set up the same. You need to know your mass of your water in order to eventually get a mole amount for your water. Well, the difference between a hydrate and an anhydrate is the water that was driven off. So to determine what number goes here, it's just a subtraction. Subtract away the amount of anhydrate from hydrate, and the difference will be the water. So if I subtract those from one another, I get 11.36 grams of water. Now again, to determine this, this is a mole ratio between water and basically the anhydrate. So what I'm going to do is I'm going to take my water amount, make it mole, my anhydrate amount, make it mole, and then compare those two and figure out what my mole ratio is, and that should give me my number. Now what I've calculated here is the actual amount of moles of water and anhydrate within my cobalt chloride hydrate. Okay? Within this substance, if I have 11.36 grams, I've got this many moles of water. If I've got 13.64 grams, I've got this many moles of cobalt chloride. To get this X again, that's the mole ratio between water and cobalt chloride. So if I look at this, what I'm looking at here, similar to what we did when we did empirical formula, is what's my ratio between my moles right now? And what I do is I take my bigger mole amount, divide by a smaller mole amount. It'll always be the water that's your bigger. Okay? And when you divide them, what you find is it's basically a ratio of times 6. Okay? You have 6 times as many moles of water as you have of your anhydride. So that means right here, this X is that you have 6 moles of water within that cobalt chloride. These are 2 problem types. You got to be familiar with them before the lab tomorrow. So go ahead and do the form, which is some practice, and have a nice night.